I love my Ego power tools. I've got a bunch of tools for the yard, and I've got a bunch of batteries. I even have some not so genuine batteries like this one here that I've tested out on the channel before. And I've also reviewed something like this, which is a portable inverter that you can have some emergency power using the batteries you already own to just slap on here. It gives you an AC output, some DC outputs, and a hitch. That thing will work great. But what if you need more power, or if you want maybe a more quality inverter? Because this says it has a pure sine wave inverter, but I'm sure the inverter in something like this is much cleaner, much nicer. How can we get the power that's stored in this battery put in here so we can use it at a much higher rate and use all of our Ego batteries to keep this thing running longer? Well, in this video, that's what I'm going to do. Or at least that's what I'm going to try. So wish me luck. Hey everybody, it's Chris from FamilyGeekery, and today we're going to be testing out using our Ego batteries to either charge up or extend the life of a portable power station. Now I'm going to be using this ARC packs here, which I reviewed recently on the channel, but this will work on basically any large power station like a Bluetti, EcoFlow, Anker, as long as it's within the voltage specs of what we're going to be draining out of this battery. And I'll make sure that I explain all that to you in this video. But to get this done, of course, we could just slap this thing onto this thing, plug this into here, and get some power from here to here, but that's not very efficient. So we're not even going to be using this in this video. Instead, we're going to be using this little adapter here, which I bought on eBay, and I'll leave some links down in the description below, because the guy that made this for me on eBay, he was super nice. He had great communication. He even asked me what kind of, application I was going to be using it in so he could make sure that it was the right one. So like I said, I'll have some links to this. He's got a couple different shapes and sizes, and I think he can make some for other power batteries too. Now I've done a similar thing like this on a smaller scale with the Ryobi battery for the 18 volt batteries. And I wanted to see, hey, what if I step it up to 56 volts with these Ego batteries? How well is that going to work? So that's what we're going to be testing out. Now, the first thing we need to consider is what the voltage input of our power station is. And because this is 56 volts, and we're basically going to be building a solar panel simulator, for lack of better terms, and plugging it into the solar input, we want to make sure that the solar input spec on this thing will allow that. Now, on this particular ARC packs here, I know it goes up to 60 volts with a max of 400 watts input. So this 56 volts is going to be just perfect for it. But if you had a smaller power station, make sure you check those voltage specs, because some of the smaller ones, actually most of the smaller ones, have input limits of like 28 to 30 volts. So if you have something smaller like a EcoFlow River series that has that 28 volt max, then go check out my Ryobi video. That's the way to go. But if you've got an EcoFlow Delta 3 or Delta 2, they have inputs up to 60 volts just like this one, so it'll work exactly the same. So once you're sure that your power station is going to accept this battery, then we're good to go with the rest of this. Alright, so when I made this for my Ryobi batteries, I just connected on a XT60, which was perfect for my EcoFlow River series, and it works great. But for this one, I wanted to have a little bit more flexibility as to what I plugged it into. So with that in mind, what I did was I crimped on some MC4 connectors, and this way I can just use any kind of adapter like this guy right here, which is MC4 to, about 4 different solar inputs. And then I can basically hook it into any compatible power station. Now to put these connectors on, I just got a Bouge RV connector kit, and it comes with the crimper and about 12 sets of MC4 connectors. And it was super easy to do. I'll leave a link down to that below also. And with the amount of cable that they had here, it was perfect to just crimp these on. But I do want to have a fuse on here like I do. I have an inline fuse just in case. So instead of using an inline fuse, I've got an inline fuse which is a MC4, male to female, that goes just in line here with the positive lead. Now the cable that the guy installed on this is 10 gauge cable, which is going to be plenty fine for the amount of current that's going to be drawn from this battery going into the power station. And like I said, just in case, I've got this fuse in line. So we'll just go ahead and snap that right on here, and we are ready to go. Now I'm sure if we asked the seller of this product if he'd put an inline fuse in there, I'm sure he could do that, but for me this was just as easy. Now when you do this, you want to make sure that you get the right ends on here. And since we're basically just simulating a solar panel, I just looked at a solar panel to see which one was positive, which one was negative, and that's the way that I crimped them on. So this is the negative one that I crimped on, and then the positive one, of course, looks like this. So when you go ahead and plug that into your adapter that's going to go to your power station, you just match up the connectors that match. In this case, the colors also match also, which was a good way to verify that it was the right connectors. Now, if you do want to verify that your crimps were done correctly and safely, what you can do is take an extension like this, pre-made extension, and then snap it onto these conductors here, and then do a continuity test all the way from one end of your positive to the positive tab here, and then do the same thing from negative to negative. And then that way you'll know that you have a good continuity, strong signal all the way from here through this and then through the pre-made cable. And that's telling you that at least the connector inside here is mating correctly. And I'm sorry I didn't show that on the camera, but since I do have this already hooked up, we can just go ahead and do the same thing. Grab my DVOM here, put it into continuity mode, test the leads real quick. Alright, and let's just go into this positive one here on this connector and go all the way to the positive, and that is good. And we'll do the same thing, go from the negative here to the negative, and that is solid. So I think we are good to go with our crimp and our cable. So let's start hooking this thing up. Alright, so to hook this thing up, we're just going to slide the battery right onto this little sled here. And like I said, the seller had several different models of this, even for the Ego batteries. And this one's got a little clip on it, which will lock this battery on. I thought that was the smartest one to use. So let's go ahead and just flip this battery over. And we're going to put this down here, slide it right in. And it snapped on pretty good. It's not going anywhere. So now that is ready to go. So now we just have to go ahead and plug it into our power station. So let me bring this a little bit closer. And the XT60 connector's on the back, so let me plug that in. And that woke up the screen here, so we should start to see some of the power flowing in, and there it goes. And we're up to 70 watts, 190 watts, 266, 357, and 400. Okay, so the max input on this is 400, and it's going to go ahead and use its internal circuitry to dictate that for us. It's not going to draw more amps than what it needs to get to that 400. So since the voltage is constant at 56 volts, if we look at basic calculator here, 400 watts divided by that 56 volts is about 7.14 amps. And that 7.14 amps is going to be nothing compared to what this battery can deliver. These smallest batteries, the 2.5 amp hour batteries, can deliver 20 amps of power non-stop. Think about what it's plugged into: weed whackers, chainsaws, even riding lawnmowers now. So this 7 amps is nothing compared to the 20 amps that it can run constantly. And as you go up in size and battery, the 5 amp hour batteries are like double that. They're like 40 amps. And then the 7.5 amp hour batteries can provide like 60 amps. So for this 400 watt input, this thing is going to be nice and fine. Now I've got a cheap clamp meter here. We can turn that on to amps. And I'll just clamp this positive lead here. And it's not super accurate, but it'll tell me something. And it's showing like 6.7 amps. So that's pretty close to what we calculated at being what's probably closer to 7 amps. And I would believe this a lot more than I believe that little silly clamp meter. But it is rocking and rolling. It's holding this 400 amps, no problem. These cables are not going to get warm at all. This battery's not going to get hot. So I think our test is a success. And basically, what I wanted to test was if I had an emergency or a power outage or something, and I was using this power station here to maybe keep my refrigerator going or keep all the household essentials going, would I be able to top it off or backfill it or keep it going with a bunch of Ego batteries from my garage? And I think the answer to that is yes. Now at 56 volts, if you had like a 5 amp hour battery, maybe something that came with your lawnmower or your leaf blower, the 5 amp hours times 56 volts is going to be right around 250 watt hours or so, a little bit more than that. And this power station here, much like the Delta 2 or Delta 3, is about 1,000 watt hours of power. Then you would need like 4 batteries like this to fill it up. Now I know in my case I've got a lot more than 4 of these batteries, so I can keep this thing filled up for more than double the lifespan that it has built into it. And even though this not so genuine battery says 12 amp hours, I know that's not true. This is still 3 to 4 amp hours. So it's still able to deliver, 200 or so watt hours of power into this battery pack. Of course, losing a little bit from the conversion, there's going to be some efficiency loss. But I think our little test here is a success. Alright, so I'm happy with our little test here with our Ego battery going into a power station. And just think, this could work for basically any kind of power tool that you have. You just have to make sure that the voltage fits the power station that you're using. If you have the Ryobi 40 volt batteries, that would work for this same situation too. If you had 20 volt DeWalt batteries, that would work better for the smaller power stations, of course. But I know they make these type of adapters for basically every kind of major brand of power batteries, because people run their go-karts and stuff off of them. So just see what's out there for your battery. If you have any questions on how to hook it all up, let me know. Just leave a question down in the comments below. But I hope you got something out of this video. I hope it was helpful to you. If it was, I appreciate a thumbs up. I'll leave links to all these items down in the description below to help you build up your own little portable fake solar panel for your power stations. But go ahead and check out the rest of the channel. I've got lots of other nifty stuff in there regarding these power stations and solar generators. But I think that's going to wrap it up for this video. I thank you as always for watching, and until next time, peace out and geek out.